We now talk about Snell's law of refraction. So we will derive this Snell's law of refraction from the Huygens principle. So say you have a wavefront A, B prime, and you have these incident ray. So there are a large number of parallel rays which are coming like this. So we are taking two rays out of it. So say this ray comes down and this ray is coming down. So it falls on this material and then it gets refracted. So I is the angle of incidence, R is the angle of refraction. So these two rays are parallel. So I is the angle of incidence, and then you have an angle of refraction here. So I is here and R is again here. This R and this R are same, this I and this I are same because these rays are parallel to each other. Now let us fill up this rectangle AB prime C. So the first thing to notice is that since this AB prime is a wavefront, this is perpendicular. Now this angle is, because this normal is always perpendicular to the surface, this angle is 90 minus I. This implies this angle is I. Similarly, this angle is 90 minus R. So this implies this angle is R, since again this is a 90 degree. So this is another wavefront BC. So let us now talk about how the wavefronts are traveling. So when the first ray hits the medium, the second ray is still traveling. So the second ray here is at B prime when the first wave has hit point A, and AB prime is the wavefront. So by Huygens principle, say the ray enters the medium, it travels to point B. So in the same time, the ray will go from B prime to C. So AB is the distance the ray has traveled into the medium. In the same time, this ray too will go from B prime to C. So let V1 and V2 be the speed of light in the medium 1 and medium 2 respectively. So that means that this distance B prime C, this distance is equal to speed in medium 1. So this is say medium 1, and this glass is medium 2. So B prime C, this distance is equal to velocity multiplied by small time delta t in which this wave travels. So this is B prime C. AB is again the velocity in medium 2 times small time delta t. Now you focus on the triangle AB prime C. So in the triangle AB prime C, sine of I, so sine of I is equal to opposite side over hypotenuse. Opposite side over hypotenuse. So opposite side in this triangle AB prime C, opposite side is B prime C. So B prime C, hypotenuse is AC. So you have sine of I is equal to B prime C, which is V1 times delta t divided by AC. Similarly, in the triangle ABC, so in the triangle ABC, sine R is equal to opposite side. Opposite side here in this case is opposite to angle R. Opposite side is AB over hypotenuse, which is AC. AB is V2 times delta t. So that is what we have plugged in. Now you divide sine I by sine R, that is divide this by this. AC will cancel out, delta t will cancel out. You will just get V1 by this V1 by this V2. So this is the equation we get. So this is equal to Snell's law. This we will just show. So the refractive index of the material is defined as speed of light in vacuum divided by speed of light in a medium. So say for medium 1, N1 would be equal to C by V1. For medium 2, N2 would be equal to C by V2. So this implies V1 is equal to C by N1. So this implies V2 is equal to C by N2. So you plug this in. Instead of V1, you put c by n1. Instead of v2 you put c by n2, so this becomes equal to n2 by n1, or we write it as n21. So this is what the Snell's law is. Now if r is less than I, so we focus on this equation. Now if r is less than I, that is denominator is less than numerator, then v2 has to be less than v1. So that means if this angle r is smaller than this angle of incidence, so that is this ray is closer to the normal as compared to here, then velocity in this medium, this v2 is less than v1. Or you can say if the velocity of the ray on entering the medium becomes less, then the angle of refraction is less than the angle of incidence. So we are doing nothing, we are just using this equation. So this could go either way because you have a equality sign. So if the ray is bending more towards the normal, so if angle of refraction is less than the angle of incidence, that is the ray on entering the medium bends towards the normal, that means that the velocity on entering the medium actually decreases. And that is what the equation says, and vice versa. Now we just say that if the wavelength of the light also changes, say wavelength is lambda 1 in medium 1 and lambda 2 in medium 2. Now this wavelength, the ratio of wavelength is same as the ratio of velocity. So because the distance and the time have to match. So the time is the same, so that means the ratio of wavelength has to be equal to the ratio of velocity. So this you can again plug it in here to get sine I by sine r is equal to lambda 1 by lambda 2. So again you can say if r is less than I, then denominator is less than numerator, that means lambda 2 will be less than lambda 1. That is if the ray bends towards the normal or entering the medium, that means the wavelength of the wave has decreased.